Today we're going to talk about the last of the special parallelograms, and that is a square. So a square is a parallelogram, parallelogram with four right angles and all sides are congruent. Okay, so it is the intersection or a cross between a rectangle and a rhombus, because remember, rectangles have four right angles, but the sides are not congruent, whereas a rhombus, all four sides of a rhombus are congruent, but the angles are not right angles. So what we're going to do is we're going to kind of go shape by shape to notate and write down the properties of a square. So first, the properties of a square, given that a square is a parallelogram, you have all the properties of a parallelogram. And there are just all of those from a couple days ago, and there are a lot to list. So we're not going to keep listing them all. But remember, parallelograms have opposite sides are congruent, opposite angles are congruent, and then the diagonals bisect each other. Okay, 2, 3, 1, 2, 3, 4. So you may be asking yourself, well, why are we writing down or marking up this picture of a square based on the properties of a parallelogram? And the reason for that is because marking this picture up and reminding ourselves that a square is also a parallelogram will remind us to use parallelogram properties when we're solving problems dealing with squares. Like if we're looking at the diagonals here, and I said that if this shape was a square and that this side was 8 feet long, you could then conclude that this side is 8 feet long because you're using the properties of a parallelogram. Now, if a square is a rectangle, what properties exist? There aren't that many additional ones. It's that the diagonals are congruent and all angles are 90 degrees. So a rectangle will have four right angles and the diagonals are congruent. So we'll mark that. Now, if a square is a rhombus, what properties exist? So we have three properties here to write down. All sides are congruent. All sides are congruent. The diagonals are perpendicular, so they form a right angle. And the diagonals bisect the opposite angles. The diagonals bisect opposite angles. So what that would look like is we would have all four of our sides congruent. We would then draw our diagonals. Our diagonals are perpendicular, and our diagonals bisect these opposite angles. Okay, so now what we're going to do is we're going to kind of combine all of that information in this picture here. So if this is a square, this picture down here is a square. our angles are right angles here at the diagonals, because in a square, the diagonals are perpendicular just like they are in a rhombus. Well, just like in a rhombus, these angles are congruent. Okay, and these angles are congruent. Well, the angle measure of those angles has to be 90 degrees, because these two angles are the same if you call them x and x, and this angle is 90 degrees. That makes these have to be 45. So all of these angles here are 45 degrees. So then what type of triangles are formed by the diagonals? They are right triangles. Right triangles. So down here, first example, we're going to determine if these statements are true or false. All squares are rectangles. That is true. All squares are, in fact, rectangles. Squares are special types of rectangles. You could think about a square as a rectangle where all sides are congruent. All rectangles are squares. That is not true, because the conditions on a rectangle are just that the angles are all 90 degrees and that the diagonals are congruent. Nothing about the side lengths of a rectangle are needed to determine if the shape is a rectangle or not. So this is false. All rhombuses are squares. That is also false, because we know a rhombus does not have to have all four angles be 90 degrees. So that is false. All squares are rhombuses. That is true. A square has all the properties of a rhombus, that the sides are equal, the sides that are all congruent, and that the diagonals bisect each other. So all squares are also rhombuses. All right, let's go to the next page. We have the diagonals of square EFGH intersect at J. Given that GJ is 15, find the indicated measures. So we have 5 things we're asked to find. Since we know that this is a square, we know that all the angles here at the diagonals are 90 degrees. We also know that all of these smaller angles created by the diagonals are 45 degrees. And I'm not going to write all of them here. I'm just going to write some of them so that we get the idea. So letter A is asking us the measure of angle EJF. EJF, well, that's 90 degrees. That's one of our diagonals. So 90 degrees. The measure of angle JFG. JFG, that is 45 degrees. And then FH, well, how long is FH? Let's look. Well, all we have is this length right here. GJ is 90. Or sorry, not 90, it's 15. Well, because this is a square, it has the properties of the rectangle and the parallelogram, where all of these shorter diagonals, or parts of the diagonals, are 15 units long. So FH goes from here all the way down there, so it'll be 15 plus 15, or 30. EJ goes from E to J. That'll also be 15 is part of the diagonal. Now FG. FG is this side right here. Well, we don't know what that side is, but we know that these two sides are 15, and we know we have a right angle, so we could use Pythagorean theorem, where our two legs are both 15, and 15 squared is 225. So 225 plus 225 equals c squared. Combine our like terms, 450 equals c squared, and we square root both sides. We get 21.2. So remember to use Pythagorean theorem when you will have to when it comes up. All right, so here is some problems for you to try. So I want you to go ahead, pause the video, and once you're done, unpause it so that we can compare our answers. If need be, go look or rewind the video and see what we did the first part of example number 2. So good luck. All right, so these are the answers I got. What you need to be careful of at the very beginning was that FD was 20, so this whole length was 20, which made each part 10. So now let's look at example number 3. We're going to classify these quadrilaterals first and then find x and y. So if I look at A, I see that all the sides are congruent. That tells me that this is either a square or a rhombus. This angle right here, though, tells us that angle Q is not a 90-degree angle, so that means that this can't be a square. This must be a rhombus. Okay, so in a rhombus, all the sides are congruent, so 5x plus 6 equals 8x. We'll subtract 5x from both sides. 6 equals 3x. Divide both sides by 3. And x is equal to 2. Now for the angles, these two angles are not congruent. Those two angles add up to 180 degrees. These are consecutive angles. And remember from the properties of parallelogram that the consecutive angles are supplementary, or they add up to 180. So 12y minus 1 plus 97 is equal to 180. So we'll combine our like terms. We get 12y plus 96 equals 180. Subtract 96 from both sides. We get 12y equals 84, and y is equal to 7. Now, letter B. Let's look at this. And we see that all the diagonals are congruent. That's what we get from these tick marks here. We do not know if all the sides are congruent. There's no tick marks there, so we can't assume that. But because the diagonals are congruent, we know that this has to be a rectangle. In a rectangle, opposite sides are congruent. So 4x plus 7 equals 5x minus 6, and we'll solve that. We'll subtract 5x, and let's subtract 4x instead from both sides. 7 equals x minus 6. Add 6 to both sides, and 13 is equal to x. And then we'll do the same thing with y. 2y plus 1 equals y plus 3. Okay, so then we'll subtract 1 from both sides. 2y equals y plus 2. And once we subtract y from both sides, we just get y is equal to 2. Letter C, the diagonals are congruent. That's what these tick marks are. So that means that this is a rectangle at least. But because this is a right angle there as well, the diagonals are perpendicular. That means this is a square. This is a square. So that means all the sides are congruent. So 3y is equal to 42. Divide both sides by 3. Y is equal to 14. And 2x is also equal to 42. And divide both sides by 2. X is equal to 21. Now you could have done 2x is equal to 3y. It just would have taken a little bit longer because you'd have to plug in 14 for y. So I figure we didn't need to do that extra step. Doing it the way I did it here is a little bit easier and gets to the point a little bit quicker. And then letter D, the diagonals are not congruent because there's different number of tick marks here. So we know it can't be a rectangle. We also don't have a box there or something to tell us that that is 90 degrees. So that means this can't be a rhombus or anything like that. So that means this is just a regular old parallelogram. Nothing special about it. So we use just our normal properties of parallelograms. 2x minus 3 is equal to x plus 7 because in a parallelogram, the opposite sides are congruent. So we'll add 3. 2x equals x plus 10. We'll subtract x from both sides, and we get x equals 10. Okay, so you really want to have all those properties of parallelograms with you because now you're going to be using those interchangeably, and you've got to decide, okay, this is a parallelogram, and I know these things are true, but am I given other information to determine that this is actually maybe a rhombus or a square or a rectangle, anything like that? So keep those properties handy so you can refer to them when you need to. So I hope that this was a good introduction to squares and kind of a good review of how to use all these properties and determine which ones you want to use given the situation. So thank you for watching. Make sure you like this video and subscribe.